I fasted overnight, and I took this coffee that had 3 tablespoons of heavy cream that was grass-fed, 3 tablespoons of Kerrygold butter, also grass-fed, and a tablespoon of coconut oil. And you put a little stevia in it, you heat it up, you shake it in a thermos. I drank this in the morning, and I sat down to write my data. In the first hour, nothing. The second hour, I noticed no dystonia. No pain in my back. I seem to be thinking clearly.
Yeah.
Tremor, almost none. And the only thing that I had was dyskinesia. And I had dyskinesia at the time because I was taking just about every known drug, and I was at the end of where you can still increase the medications. I was on 6 different medications at the time. So second hour, everything's good. And there's this phenomena called on-off. I could usually expect to be on, which wasn't really that good, about 1 hour of every day.
On meaning you can focus, it's productive, etc.
It's a term that people who have Parkinson's would know. When you get into the advanced stages, you're losing other neurotransmitters, other parts of your brain. Dopamine is the first one that they think is related, but you also have adrenaline, serotonin, these other molecules that you're not producing, and it leads to these symptoms that are very difficult to treat. And one of them is the inability to stay on during the day. So what happens is you fluctuate. You go from being able to write to all of a sudden, what am I writing about? And so all these things changed, and as I went through my form, at the end of the day, I had been on the whole day.
Wow.
And the next day, I think I remember eating some carbohydrates. 2 hours later, it was gone. And but that was an amazing thing to experience, because I hardly remember what it was like to shake all the time and have dystonia, and rigid. You know, you just felt like you couldn't do things, and you sigh, and to feel like a normal person almost all but 1 or 2 hours of the day is just amazing.
Hello there, welcome back to another video. I'm your host, Mike Mutzel. As always, I'm so grateful, I'm excited, I'm honored that you're here, that you're watching this, that you're listening to this. This episode is proudly sponsored by SomniFix. As you know, I'm a huge fan, and many of our guests are fans of deep restorative sleep. One way to get that deep sleep is to ensure that you're breathing properly through your nose while you're sleeping. When you're sleeping and your mouth is hanging open wide, and you're in those deep phases of sleep, your tongue can actually collapse in the airway, and that can prevent you from achieving that deep restorative sleep that's responsible, or that state of which that fosters growth hormone release and repair of your body and much more. So that's why I love this, absolutely love this product, because it's a hypoallergenic mouth tape that really helps you to relearn and retrain your body to properly breathe through your nose while you're sleeping. So please check out their website at somnifix.com. That's SOMNIFIX.com. Now for today's show with William Curtis. First of all, I just want to say I'm so grateful for this discussion. And this discussion with William would not be made possible without Frank Yosa, who I'll post a video right here that Frank and I did where we tested the ketone ester. So you can find him over at ketoneaid.com. And Frank's an awesome guy. So he got to know William through Richard Veech. And Richard Veech, as you know, has been a huge pioneer and scientist, helping us to better understand the ways through which ketone bodies are made, how they're utilized in the body, and pioneering the work and the development of the ketone ester product. So as you gathered from the introduction, William, over 17 years ago, was diagnosed with Parkinson's. And he was told by his doctor that he may have 10 good years of functioning left. And William decided that, he didn't like those words, and he wanted to beat his diagnosis, if you will, overcome, do whatever it takes to ensure and to maintain optimal function in his body. And as he's going to talk about and reveal in this video, fasting, exercise, and the ketogenic diet were some of the main modalities that he's found to be, as he described, to be more on, to be more cognizant, to have to abate some of the classic Parkinson's-like symptoms. So he's going to talk about that, some of the things that he's learned, and how he's able to help other people that have Parkinson's, that are on multiple medications, help them regain and reclaim some of the functioning of their body through diet, lifestyle, and exercise and fasting. And then towards about, I want to say 35 minutes into the interview, that's where it really gets good and juicy. If you're really interested in learning more about the complex biochemistry, the ways through which ketone bodies affect cellular redox. I know it gets a little complex, but it's really good stuff. Just as always, click the link below this video or tap that button in iTunes, and you can look at the show notes and fast forward to that. I would suggest listening to that at least twice because he does use some complex language. And I think it's important for those of you guys that want to take this to the next level and really understand how the ketogenic diet and the associated metabolic milieu that's achieved when we fast, when we exercise, or when we eat a low-carb ketogenic style diet, how that affects how that affects our biochemistry on a deeper level. So it's a great discussion. I really hope you enjoy it. I'll be following the comments as always, and so please type in a comment or hit that like button if you like this video, and let's dive right into it with William.
Hello friends, it's Mike Mutzel with High Intensity Health. Thanks so much for tuning back in. Today we're with Bill Curtis, and we're going to talk all about the ketogenic diet and Parkinson's, and he's going to kind of explain to us where he was before, movement-wise before you started exogenous ketones and doing intermittent fasting and all that. So first of all, I'm really grateful to have you on. Thanks for being here. So let's kind of talk, for the first 10 years after diagnosis, kind of where your movement patterns, how they were.
I've had Parkinson's since 2000, so it's easy for me to see how, 17 years is what's gone on. And when I started, my doctor said, Bill, the good news is you probably have 10 years before you'll really be dramatically affected by this. And sure enough, at 10 years, everything sort of fell apart. I had, I guess, if I walk now, you can't tell I have Parkinson's, and I have just a very slight tremor sometimes I don't have it, and that's about the only symptoms that I have now.
Yeah.
But at the time, I lost my job and was unable to work. If I'd write a sentence, I would start the sentence, and then I'd forget what I was writing, and I'd have to go back and read it in order to complete the sentence. So I had cognitive impairment that was really debilitating, kept me from working. And besides the cognitive impairment, I also had fatigue. I remember just washing windshields on a car was just all I could do, and I felt like I had to sit down. And I had what's called bradykinesia, short gait. When I'd walk, I would walk something like this. And I had a tremor that exceeded 4 inches, both sides. I was on about 1 to 2 hours every day. Now, on and off, that's something that Parkinson's patients know when they're advanced, because it means that the drugs only work occasionally for some reason. And it's poorly understood why this happens, but when I was off, I would have dystonia. Dystonia is tensing of your muscles, and my toes would wrap over each other, and I'd have to put silicone in between my toes to be able to walk, and I was rigid. All the typical symptoms that you see in advanced Parkinson's, incontinence. I would be watching TV, and if an ad came on, you could ask me what show I was watching. I didn't know.
Wow. We'd
go see James Taylor in concert, and I'd say, wow, we haven't seen James Taylor before. My wife would say, yes, we have. And I was really in bad shape.
Yeah. And then, now obviously no one, I doubt our viewers would know this by watching now. You seem totally cognitively, with it and moving very well.
Yeah.
But if you were talking a little bit, if you were to have carbohydrates, for example, right now, if you were to have donuts or bagels, what would we see?
Well, within about 2 hours, I would start to shake, and I would feel rigid, and I would maybe get dystonia. I don't go back to as bad as I was originally. I think I've come a long ways, and so it's more resistant than it had been. There's this thing called neuroplasticity, and I think that you can achieve some improvement. I think there's also a thing where the dopaminergic neuron is about up to 4.1 meters long, and this is just all inside your brain, and it has an arbor of axons that can be 4.1 meters, but it's all split into about 250,000 splits, and it's got one nucleus, and it's got 2.5 million mitochondria. Those mitochondria only live about less than a month. So you've got to get rid of all the old ones and be making new ones at the rate of 30,000 a day at least. And I think that the ketones protect the mitochondria, so you develop a better population, and it certainly prevents the widespread destruction of your mitochondria that you would have with paraquat or something like that.
So there's some resilience in your mitochondria.
I think that my population of mitochondria may have improved. I may have more branches. I don't know. But I do think that I'm much more resilient now than I was.
Yeah, awesome. Well, let's pull up some chairs and talk about the science.
Hey, it's me again with a brief announcement from our friends at Health IQ. I'm super excited to have them as a sponsor of this podcast and many other episodes because they understand and recognize that the absence of disease does not equate health. You see, when you embark on lifestyle change, when you meditate, when you exercise, when you lift weights, when you eat a low-carb ketogenic style diet, you reduce your risk of heart disease, of cancer, of autoimmunity. And so you shouldn't have to pay as much for your life insurance compared to people that don't embark on these positive lifestyle changes. Health IQ gets it, they acknowledge that, and they want to recognize and reward that health promoting behavior by helping you save money on your life insurance premiums. You can get a free quote, see if you qualify, and help support the podcast and Health IQ's mission of the scientific wellness revolution. Please go to healthiq.com/HIH to get a free quote and see if you qualify. Again, that's healthiq.com/HIH. Let's dive back into the show.
I'm sitting there looking at 53% improvements in UPDRS scales for people who are untreatable. And it's a pretty amazing thing that you can do that, and yet I don't know what to do about it because if I tell people there's this treatment, it's a food.
Right.
So what I've done is set up a website called Fourth Food Group, and there I think people can come together as a community and learn about ketogenic diet and try to use it to become more ketogenic in order to restore the things that are going wrong in Parkinson's.
So how did you first discover the ketogenic diet? What led you to that?
Well, that's an interesting story. I'd had Parkinson's for about 10 years. And my doctor, when I originally went in to hear about Parkinson's, had told me that good news, you can expect to be fairly normal for 10 years. Okay, 10 years came and I was having trouble with fatigue. I couldn't even write a sentence. I'd start halfway through, I would figure out, I forgot what I was writing about. Have to read the sentence and write a little bit more. So I had cognitive impairment, fatigue. I walked with very short steps, and I would freeze. If something got in my way, I couldn't take another step. I had pain that was pretty serious, and just a number of things like that that kept me from being able to work or anything. And I was in an exercise program at the University of Maryland, and there was a section that did weightlifting, there was a section that did walking on a treadmill, and they had two versions of that, and I didn't really see much difference. So I thought, what would be the best way to have exercise do something for you? And I decided to fast overnight and exercise in the morning without taking anything for breakfast. And then my theory was that that would raise my ketone level, maybe make BDNF do something for the brain. That was basic theory. And I had had serious fatigue problems at the time. I can remember just washing the windows on the car. Felt like after I got the first window done, I couldn't do any more. And I did this exercise thing, and the next weekend I was at my father-in-law's house, and he had just pulled down a tree and had all these roots. And I got out the axe and all these instruments of destruction, and I chopped for 4 hours.
Wow.
It's like, where'd that come from? And I told my wife, this is really I think I may have figured out something about prescriptive exercise to go into ketogenic state, and look what it does for my fatigue. And then a couple days later, I was doing an adjustment to the experiment where I took G2, and it killed the effect. I was back to, couldn't wash the windows.
Mm-hmm. What's G2 for people that don't know?
Gatorade has a product that you take for carb loading. It's basically a lot of sugars.
Right.
And if it was because I was going ketogenic, the sugars should have killed that. And they did. My wife said to me, "What happened to your miracle cure?" And I'm going, well, it's really neat. I was doing this experiment, and I figured out that if I took sugar, it would totally mess it up. She says, "You're going to stop that experiment right now."
Yeah.
Because it's really a stress on the spouse of someone who has Parkinson's to, you lose a lot.
Right. If you don't mind talking about, like, how long did it take you to get back to that state? So you took the sugar, you were doing really well, and you kind of wanted to prove it to yourself that one of the mediators was ketones that would
Right.
help your state. You took this G2. How long was it before you were back to kind of where you were normally?
Well, that solved a few things, but it didn't solve everything. It wouldn't last. It got rid of the fatigue, and it improved a great deal, but we were just learning things. And it's at that time that I wrote Dr. Veach and said, I tried this with another gentleman who could do 1,000 sit-ups and had Parkinson's. Totally different type of person. He could probably do 100 push-ups without blinking. And he had been my youth pastor at a church. And I started talking to him about it, and he says, "Do you know anything that'll help ED?" I go, "ED? What's that?" He says, "Erectile dysfunction." And that'll come into the story later. But
Sure.
Anyway, he tried this regimen of fasting overnight, exercising in the morning, didn't do a thing. And that's when I talked to Dr. Veach, and he says, people who are already fit don't make ketones. And then so it turned out not to be a general solution for people, and I was also told that you can't recommend this to people who are having balance problems, because if they have low blood sugar and they have orthostatic hypotension and they go into exercise, they're going to fall, and then you're going to be liable. So don't recommend this treatment to anybody. Okay. So I did that. And I did that for about a year, exercised every day, absolutely every day, got down to 220, and it stopped working fairly well. And I was also told that when you become fit, you make less ketones, so there you have it. That's not a very effective means of doing things. So I found out that as I got in shape, I wasn't producing ketones, so I contacted Dr. Veach and asked him about that, and he sent me a paper saying the athletes who are well trained don't produce ketones the way that a person who hasn't been training at all does. So I had an initial effect that seemed to go away the longer I tried to do this simply by fasting overnight and exercising in the morning. And Dr. Veach is somebody who was trained by Hans Krebs. And Hans Krebs is probably the greatest biochemist of the previous century. He did the Krebs cycle, the urea cycle, did all kinds of other things. But Veach was in his lab and one of the better students, and he works at NIH. And he also has a paper that was published in 1995 that explains pretty much how ketones work. And it's often cited, but very few people understand what it really means, because he uses math equations in his paper, and one of his lab collaborators actually said, for every equation in your paper you lose 10% of your audience. That guarantees that no paper that he ever wrote was ever listened to by anybody, because they all have more than 10.
Yeah.
Anyway, so there's Dr. Veach, and I was sitting with Dr. Veach one day, and he got an email. And the email said that if you drink this bulletproof coffee, you should be able to raise your ketones up to 2.5 millimolar. And he said, Bill, why don't you try this for a week? Because if you do it longer, you'll kill yourself with all the fat. So I wrote down every symptom that I had and divided it up into hours. And by hour of the day, I would ask myself the question, did I have bradykinesia in the past hour? Did I have a serious tremor in the past hour? Did I have cognitive impairment? Did I have pain? Did I have dystonia? My feet would curl their toes, and my legs would just be cramping. That's dystonia. And so I took this, I fasted overnight, and I took this coffee that had 3 tablespoons of dairy, heavy cream that was grass-fed, 3 tablespoons of Kerrygold butter, also grass-fed, and a tablespoon of coconut oil. And you put a little stevia in it, you heat it up, you shake it in a thermos. I used to use a blender, which is terrible.
Because of plastic and the heat, or?
The heat pops the lid off.
Yeah.
So, yeah. So I was doing this in the blender at the time, but I drank this in the morning, and I sat down to write my data. In the first hour, nothing. The second hour, I noticed no dystonia. No pain in my back. I seem to be thinking clearly.
Yeah.
Tremor, almost none. And the only thing that I had was dyskinesia. And I had dyskinesia at the time because I was taking just about every known drug, and I was at the end of where you can still increase the medications. I was on 6 different medications at the time. So second hour, everything's good. And there's this phenomena called on-off. I could usually expect to be on, which wasn't really that good, about 1 hour of every day.
On meaning you can focus, it's productive, etc.
It's a term that people who have Parkinson's would know. When you get into the advanced stages, you're losing other neurotransmitters, other parts of your brain. Dopamine is the first one that they think is related, but you also have adrenaline, serotonin, these other molecules that you're not producing, and it leads to these symptoms that are very difficult to treat. And one of them is the inability to stay on during the day. So what happens is you fluctuate. You go from being able to write to all of a sudden, what am I writing about? And so all these things changed, and as I went through my form, at the end of the day, I had been on the whole day.
Wow.
And the next day, I think I remember eating some carbohydrates. 2 hours later, it was gone. And but that was an amazing thing to experience, because I hardly remember what it was like to shake all the time and have dystonia, and rigid. You know, you just felt like you couldn't do things, and you'd sigh, and to feel like a normal person almost all but 1 or 2 hours of the day is just amazing.
Right.
So
that kind of solidified for you, you know, putting 2 and 2 together with the fasting, the improvements in symptoms, and then kind of this bulletproof style coffee in the morning. You started to realize that some of the molecular mechanisms may be the ketones that are affecting things. And then so that kind of fostered a relationship with Dr. Veach.
Well, I had a relationship with Dr. Veach because we had originally emailed back and forth, and I went into his lab because I was over at NIH looking up papers, and I thought, hey, I'll call my aunt. She wasn't there. She works at NIH. I'll call somebody else I know. I called Dr. Veach, and he said, yeah, come on over. So I met him in person for the first time, and he was talking about how his lab was going to be shut down because he didn't get the right score, and I thought that was a travesty because, you know, from what I've read of his papers, he has some hypotheses about what can be treated with this, and it's equivalent to the effect that vaccines or antibiotics would have, because if you look at the diseases that it potentially could make a really significant difference in, just take 3: diabetes, Alzheimer's, and cardiovascular disease. Those 3 are growing tremendously and are going to put a terrible burden on our Medicare system. So if it is effective in those 3, just those 3 diseases, you know, that's easily equivalent to vaccines or antibiotics.
Right.
And there is some evidence that it does amazing things. Dr. Veach proposed that it should prevent the damage from ionizing radiation. And the military has done an experiment with Dr. Veach's ester, and they took mice and exposed them to doses of radiation, and taking just a single dose, which would be, for me, it would be about half this bottle.
Well, let's explain. That's a ketone ester.
Yeah, this is a ketone ester.
Okay.
It's Dr. Veach's, but it's not made by his lab. It's made someplace else. And
you have that just in case throughout the day you carry the ketone ester with you?
well, I don't normally carry it with me. I carried it here for this interview.
Sure.
But what it does is you take a single dose, if you're a mouse, and it can decrease the death rate by 50%. Just one dose 24 hours after you've had an LD70 dose of radiation.
Wow.
Just amazing.
That is amazing. Huh.
You'd think, how does it do that?
Right. Yeah.
So there is some evidence that it does just amazing things. And the ketogenic diet is a little bit of a problem because you can imagine eating 80% of your food by weight or 90% by calories as fat.
It's hard for a lot of people.
It's hard for anybody.
Yeah.
So what I've done is taken the approach that there's sort of 3 levels that you can get into it. One is just fast overnight and drink the coffee and don't worry about your diet. And people have responded to that, and then they'll write me and say, this is amazing, it works. And then they'll run into a problem. You know, just like when I ate the carbohydrates and a couple hours later everything was gone. And what they say is, work great for 3 days. Now what do I do? Stop working. Okay. So let's troubleshoot. Did you eat too much protein? Because proteins tell the liver to make glucose. Proteins break down into amino acids, and most of them turn into sugar.
Right.
So just like when I took the C2, killed it, when you take too much protein, and you should take like a the size of a box of cards in protein, and that's about it. You know, don't get these
8-ounce T-bone steak and all that.
oh yeah, no, it'll be all over.
Yeah. Have you, on the topic of protein, have you found other proteins to be more gluconeogenic than some? Like some people say, oh yeah, eggs will kick me out of ketosis, or beef.
No, that's interesting. I haven't found that.
Okay.
I did find that pork rinds will kick me out.
Interesting.
And I think that's because of too much protein, but you know, a lot of people eat pork rinds on a ketogenic diet in place of potato chips, but
not a good idea, and at least for you.
For me, that's just an observation that I found. And another thing that happens when we're troubleshooting with these people is that I'll ask them, did you eat carbohydrates? Most people don't know where the carbohydrates are.
Yeah.
And it's amazing, you know, you get these comments like, well, meat has carbohydrates in it, doesn't it? No. So we give them a list of low carb foods, high carb foods, and so I said there were 3 levels. The first level is just taking the coffee and fasting overnight, not eating everything in a 6-hour window from 12 to 6. The next level is to limit your carbohydrates and your protein. So you're not on a ketogenic diet, but you're limiting your carbohydrates and protein, and that does great. The third level is to go with a ketogenic diet. That's real hard to do. Fortunately, my sister is a great cook and lives with us 6 months out of the year, and she has some beautiful recipes, you know, that have all kinds of vegetables and healthy foods and are still ketogenic. And when I'm at that level, I get some really good response that I don't get when I'm at the medium level. So there's 3 levels: the coffee, low carb, low protein, and then there's full-blown ketogenic. And I'm the only person who has tried the full-blown ketogenic, as far as I know, in talking with all these people who email me. And most people who email me settle on just the coffee in the morning, and they don't have to use that recipe. There's a lot of good ones that, you know, vegetarian, use egg yolks, use MCT oils. There's any number of recipes, and I really appreciate that these people try these things. A lot of people will avoid milk because there's some studies that say that milk products are correlated with the onset of Parkinson's. Well, in every country except Japan, but so they may not want to take cream, and so there's any number of ways that you can do this, but you basically have 3 levels. And then there's maybe a 4th level where I mentioned this ester.
Yeah.
Okay. What I found there was if I go to lift weights, it causes a serious problem, and this is part of troubleshooting. When you lift weights, you produce a lot of lactic acid, and it doesn't clear right away. It may take a day to clear. And the way that it clears is called the Cori cycle. You're familiar with that?
Yeah.
So the lactic acid comes out of your muscle, goes into your liver, it's turned into sugar. Remember the C2? Same problem. If I lift weights, I can be off the whole next day. So what I do is I take ketone ester before I lift weights, and glucose breaks down into pyruvate, and if you're anaerobic, you're going to make lactic acid. The ketone bodies, beta hydroxybutyrate, go straight into the mitochondria and never make lactic acid. There's no way for them to make lactic acid. So what I can do is take the ketone ester and totally avoid this problem of
feeling sore and tired.
Cori cycle of my body making the lactic acid into glucose for 24 hours. So
even while you're doing anaerobic type work,
Yes.
Okay, so that's an important. There's a lot of controversy about ketones in the internet. Some people are, like in the carb cycle, in the carb world, I should say, because they feel that if you're doing anaerobic, short duration, high intensity type work, that you have to break down glucose for that. But you're just saying here as well, we're really breaking down glucose to make acetyl-CoA anyway. Why not get the acetyl-CoA from the ester, and then you don't get any of the lactic acid?
Exactly.
Which sounds really interesting.
I'm sure you do still make lactic acid. It's just a
smaller amount.
And
That's fantastic. One thing that came to mind that we didn't address, you were in the flow, so I didn't want to interrupt you.
Sure.
It was a comment earlier when we were talking about exercise, and when you discovered for yourself that after time the exercise wasn't working as well in terms of causing remission of your symptoms. And Dr. Veach had mentioned something that athletes don't make as much ketones compared to the average Joe.
Well-trained. Yeah, an athlete. Right.
Can we talk about levels? For people at home are testing and tinkering and all that sort of stuff. So, because I know myself, my levels don't really, if I'm fasting and eating a low carb diet, don't really get above 1 millimolar.
That's about mine too. We could test mine now and see what they are. I do notice that when I'm on the ester, my numbers go way up, 4, 5, and there's a couple things in particular that really stand out at that time. I can write very clearly, and some of the papers that I've written, I was taking ester, so it made all the difference in the world. And the other thing is, I mentioned my pastor talking about ED. Okay, so I have this container that I keep my underwear in. It's a diaper pail, and it's kind of, you don't want your wife cleaning out your underwear if you're having incontinence. And on the 10-day period when I took the ester just to see what it did, keeping notes, you could look through that diaper pail and everything would be tighty-whitey. No urinary incontinence. And you think, well, that's not a big deal, wear pads or something, but it really has a lot to do with your self-esteem. And so as you go up in level, there are symptoms that improve, that are measurable.
And pretty significant.
Yeah, but for most people, you can get most of the benefit just from the 3 levels of the diet.
Like we kind of talked about.
Yeah.
So I know you're kind of speculative here, but after going through all this, 10 years, trying naturally, doing exercise and stuff, now getting more into the keto, now the keto ester, for folks listening at home, if they have a family member with Parkinson's or it runs in their family, would you speculate that this lifestyle, this low carb ketogenic style lifestyle, would it possibly prevent the onset of Parkinson's, do you think?
That's an interesting question. There is data saying that uric acid, which is something that is measured all the time in urine because they're wondering about kidney stones and gout. So they have all this data from uric acid, and they know that if uric acid goes up, that will delay the onset of Parkinson's. And if you have Parkinson's, then the uric acid, the people with high uric acid tend to decline more slowly. So they think it might be disease modifying. Well, there was a study done regarding polio that said that ice cream might have been related to polio, and they thought this was a serious thing at the time because the rates of polio went up in the summer, and also in the summer you'd find ice cream consumption going up. So they had these rabbits and they were treating them and seeing if the sugar was causing the susceptibility to polio. Of course, we now know that it was fecal oral contamination in swimming pools, and the swimming pools were in the summertime co-correlating with the ice cream. And you think, well, that's kind of crazy, but you have to think, well, what is it about uric acid that would do something for Parkinson's. And there are some good things that might make you think that uric acid might be working. One is that it chelates iron, and iron is toxic to dopaminergic neurons. By chelate, that means that you get a uric acid in, you can stick up to 3 of them on. It's very difficult to stick 3, but once you get 2 of them stuck on, you pretty much chelated, or the word means claw. You've
the iron molecule?
You've chelated the iron molecule and kept it from doing this oxygen cycling thing that it does to kill the mitochondria. And now, the other side of the coin is that the beta-hydroxybutyrate co-correlates with uric acid. When you are trying to excrete uric acid, you're in competition with excreting acetoacetate and beta-hydroxybutyrate, and exponentially your levels of uric acid go up when you are experiencing high levels of ketones or beta-hydroxybutyrate.
Interesting.
So it's just like the swimming pool, you know, they both went up. Which is the one that
is having the positive impact?
Yeah. And there are some interesting mechanisms for beta-hydroxybutyrate. One is that it eventually allows you to make more dopamine, serotonin, adrenaline, noradrenaline, and nitric oxide. And you're wondering, how can it do that? Well, beta-hydroxybutyrate is one of the things that affects the cell's battery. The cell's battery is NADPH, the cytosolic NADPH, and the H on the end is going to be donated as a hydride ion. That means it's going to have 2 electrons and 1 proton. So that's where your body gets all of its electrons. If you need an electron for glutathione, it comes from NADPH. If you need an electron for tetrahydrobiopterin, which is BH4, it comes from NADPH. And so you've got this battery in your cell called NADPH, and that is going to change the ratio of tetrahydrobiopterin BH4 to BH2. You're going to get more BH4. You're going to stick more hydrogens on it, which are really hydride ions and electrons. And just by making more of the tetrahydrobiopterin versus the dihydrobiopterin, you're going to increase this reaction, which is the formation of dopamine from, it goes, let's see, tyrosine hydroxylase to L-DOPA to dopamine. But the tyrosine hydroxylase uses BH4 or tetrahydrobiopterin as a cofactor, coenzyme. And when you increase the amount of BH4, you actually make more dopamine. What is it that Parkinson's are lacking? Dopamine.
Right.
So if I were taking dopamine and after an hour or so, I feel it would totally wear off. When I take the ketones, or when I do something to raise my beta-hydroxybutyrate, that lets me go 4 hours. I often forget to take my medicine because I don't have symptoms, and I let it go too long, and then it's a little bit difficult to recover. But so there's this mechanism whereby, you know, I mentioned in advanced Parkinson's there's all these other neurotransmitters and pathology in the brain. You're making serotonin, noradrenaline, adrenaline, dopamine, and nitric oxide synthase. And the nitric oxide synthase is tied to the tetrahydrobiopterin, and that's where you get your vascular opening and the urinary incontinence and the ED comes.
So we're circling back to your friend's question with the ED.
Right.
Yeah, but let's just, so I think that's, so increasing tetrahydrobiopterin BH4 via the cellular battery NADPH from the ketones.
Yes.
That's what we're seeing. So it's a lot of people are trying to supplement with BH4 with chronic fatigue syndrome and all
Sure.
this sort of thing. And I've heard mixed results on that. So this is a great metabolic strategy to help with.
Yeah, let's talk about the whole thing.
Yeah.
You try to supplement with vitamin C, vitamin E, you try to supplement with NAD, you try to supplement with BH4. What you're doing is putting in rechargeable batteries. They're like NADPH is the big battery, and you're putting in little batteries because the way that all those things work is they have an electron and they're going to give it to another molecule, but when they give it to them, they're no longer of any use. So when you have antioxidants, every antioxidant has to be recharged with an electron from NADPH. It might go from NADPH to glutathione to vitamin C to vitamin E, but it came from NADPH. So if you're like Linus Pauling, try to raise your vitamin C, it's like putting in rechargeable batteries, but doing nothing to recharge them.
Right.
So a lot of people think that most of the recharging of NADPH comes from the pentose phosphate pathway or the hexose monophosphate shunt. And it does, but that's susceptible to requiring glucose because it's an alternative way to break down glucose that can provide 5-carbon sugars for making DNA, or it can provide NADPH, and if you don't need much of that, you can shove it back into the glycolysis pathways and make acetyl-CoA out of it. But the way that beta-hydroxybutyrate raises the level of NADPH, which is your cell's battery, is that it uses isocitrate dehydrogenase in the cytoplasm. And how did it get out of the mitochondria to make NADPH in the cytoplasm? Well, you have this isocitrate dehydrogenase in the cytoplasm that's got a real, there's just a lot of it and it works very fast. So in order to get the substrate, isocitrate, out of the mitochondria, you inhibit downstream from making citrate and you increase the amount upstream, and so you have this extra, you're sort of squeezing it out of the mitochondria because there are these citrate, isocitrate carriers that allow isocitrate or citrate out. That's a -3, and it takes malate in, that's -2, so you haven't balanced it yet.
So
you
it's
still
like
have to
an
have a
exchange.
hydrogen come
Gotcha.
out. So once you do that, you balance things, but you're taking the citrate, isocitrate out of the mitochondria into the cytosol, and what's driving that is stopping it from continuing and filling it up in front of it, so you're making this high concentration of citrate and isocitrate. And then if the citrate comes out, you get a conatase, and the compound goes from isocitrate to alpha-ketoglutarate. And in doing that, you make NADPH. So that's how you're charging the batteries using beta-hydroxybutyrate. And you want to be able to measure how well the battery is charged. And what everyone does today is measure total NADPH. The fallacy there is that if you have NADPH in the mitochondria, that doesn't communicate with the NADPH in the cytosol. And they're in fact orders of magnitude different in their ratio. And there's another thing about NADPH, that it's both free and bound. The only part that is controlling and working as the battery is the free part. So what you have to do is measure the cytosolic NADPH. That's what Veach did for his first experiment for Hans Krebs. And when he found the answer, Krebs didn't believe him. Thought, you're wrong. Because the ratio was 5 orders of magnitude different from what he expected. And it allows NADPH in the cytosol to be that battery. Now the other thing he found was that once you measure just the free cytosolic NADPH, You're also able to say that when you take ketones, the ratio goes way up. If you're measuring total NADPH, you can't see that at all because you've got free, you've got cytosolic, and you've got mitochondrial. And when you measure total NADPH, there's no difference between fasted and fed. But when you measure fasted and fed using just cytosolic NADPH, you see a huge difference. So if your cell phone battery is dying or your car battery is dying, you can't start your car. If your NADPH is low, there's a lot of things that won't run well. And
now, how are these measurements done? With biopsy, or is there a simple blood test? Because we're talking about intracellular levels here.
These are actual levels that are in the tissues.
Okay.
And
So we don't have an at-home way to measure this.
What they do is, if they're using a perfused heart from a rat, they have the heart and they've got it all hooked up to pumps, and and this heart's beating. And what they do is they clip it off, and they have these lead clamps that have been sitting in liquid nitrogen, and they freeze clamp it.
Gotcha.
And that stops all reactions instantly. It's very fast. And then what they do is they measure the metabolites. And then there's some very complex math that you have to go from metabolites to the voltages and the chemical potentials, the delta G's of, say, ATP. And Dr. Veach, if he ever gets a Nobel Prize, that'll be what it's for, because he can measure all of the controlling nucleotides. You see, like NADPH is a nucleotide, and if you know its voltage, you can say all kinds of things can be affected by that voltage. You know, your amount of glutathione. And let's go back to your initial question, which was, you're trying to take NAD or
biopterin, tetrahydrobiopterin.
Tetrahydrobiopterin or vitamin C or vitamin E, and they're not working. Just taking it. It doesn't, you know, I can take those things and not see any difference in my Parkinson's.
Sure.
Your NADPH voltage is what determines the amount of glutathione that's in the plain glutathione versus GSSG. It determines the amount of vitamin C that is in the state that it has the electron to do the antioxidant, or it has the electron to restore vitamin E to its potential. So now that's not to say that theoretically there isn't an advantage to taking more of this stuff, but it has very little effect compared to being able to drive it with the battery.
Right.
It's like you were taking rechargeable batteries without having the battery recharger. And but there is some evidence that where it comes into play is that this voltage is dependent only on the relative concentrations. So it's like the difference between a single A or triple A battery and a D battery. If you have more of the stuff, then you're going to be more resistant in the case when you put a stress on that voltage. And the analogy that I think of is when you're starting a car. If you have a big battery, your voltage is only going to drop a little, and if it's well charged in a new battery. But if you have an old battery, or you have a low mixture, even though your voltage is up there, when you start the car, that voltage is going to drop, and it may drop too far for you to proceed. Now, when you get older, you have more problems, and you have less NAD, you have lower amounts of these things. So the caveat that I say when I'm saying NADPH drives everything, you still have to deal with the total amounts, and it's sort of like the voltage is determined by the relative amounts of NADPH to NADP, but there is some theory behind the idea that if you put a load on it, having more might be better.
Gotcha. To increase the resilience, so to speak.
Yeah.
Well, I guess this is a nice segue to talk about longevity, because one of the factors that I think calorie restriction kind of imparts from a metabolic perspective is these changes in NADH and NADPH ratios and all that. And you've co-authored some papers with Dr. Veach on this topic, and basically the model has been calorie restriction, and they talk about these mechanisms, but they've kind of conveniently, some of these authors have left out BHB, beta-hydroxybutyrate. And
Yeah, I think that it's poorly understood. If you didn't know that you could measure the voltage of NADPH, you wouldn't know that there was any difference. So it's completely reasonable to say we see no mechanism here. And there are some papers that say, well, we've added a dismutase or knocked out a dismutase and see no difference in aging. There's a difference in the dismutases and all the other enzymes that are antioxidants. There's two dismutases, superoxide dismutase and catalase. And the way that a dismutase works is it doesn't get its electrons from the battery. It has its own way of dealing with things. It takes two molecules, say superoxide, one molecule of superoxide and another molecule of superoxide, and it will oxidize one and reduce the other. So it gets its electrons from one of the two. And that allows dismutases to work in a special way that prevents the need for this battery to recharge them. If you think about what's going on in the mitochondria, where you have superoxide dismutase and catalase, you're spilling all kinds of superoxide in there. And when you use superoxide dismutase, it takes one step up and one step down. Well, one step up from superoxide is oxygen. One step down from superoxide is hydrogen peroxide. So you still have hydrogen peroxide to deal with. Now you've got catalase. Catalase is also a dismutase. It's going to make water and oxygen. So now you've dealt with it, and you didn't need any electrons from the NADPH. So they say in aging, well, look, we see no effect here, but where you really see the effect is in the battery, the NADPH. If you can lower the voltage, it's a negative thing, then you can affect all of the antioxidant systems. You can also affect the couple of other systems. One is the inflammation system, and the way that it affects inflammation is you've got the NADP at a stronger voltage, and that's going to talk to thyroredoxin, and thyroredoxin is going to talk to thyroredoxin integrating protein, and that's going to talk to the NLRP3 inflammasome. So if your voltage is not sustained, it releases the thyroredoxin integrating protein to go merge with the rest of the NLRP3 and cause inflammation. And there's also a feedback between nitric oxide synthase and the
HIF1 alpha.
HIF1 alpha. Hypoxia inducible factor. It sits in the cell, and if you don't destroy it, it will shut down oxidative phosphorylation, and it will also cause a lot of growth factors to be produced. But you can turn on HIF1 alpha by either hypoxia or by reactive oxygen species. And I guess I shouldn't get into this too much because we haven't published it, but so you have this ability to use ketones to restore ischemia, hyperischemia reperfusion, My brain's sort of fried.
No,
now.
you're doing great, Bill.
Or you have this ability to turn off inflammation. And in the radiation studies, we found that if you have this inflammation, it's not the original redox antioxidative damage that messes you up. It's this ongoing inflammation. And if you can shut that down, then you can really make a difference. And I think that's what's going on in the experiments where we're saving 50% of the mice from a LD70 dose.
Mm-hmm. And it's possibly by reducing this HIF1 alpha. Is that what you were alluding to?
Well, I think it's eventually by stopping inflammation.
Mm-hmm.
And the overshooting, once you start inflammation, you also have to turn it off. And there are a lot of mechanisms that are very complex. But I do think that what's happening is the NADPH, that battery, is controlling inflammation as well as there's an interesting study that says that wound healing is helped, and if you have the nitric oxide, you're going to open the capillaries and increase the blood flow. If you have the NADPH through thyroreducin, through thyroreducin integrating protein, through NLRP3, that whole system connects. And all you have to do is be able to measure the voltage of your battery. That's the missing part that all the researchers, they think that thyroreducin integrating protein should turn it on, but they don't really understand the mechanism. And it's interesting, the mechanism with the thyroreducin has a lot to do with how some of the proteins that are in Alzheimer's and Parkinson's can be accumulated, because when you control the sulfhydryl relationships in proteins, you can keep them from misfolding. And so to understand folding, I always think of going to the beauty shop to get a permanent. Your hair is held together between chains of protein by a sulfhydryl bond. Two sulfurs bond together. It's not a sulfhydryl bond, it's a thiol. And when you put beta-mercaptoethanol on your hair, it's like releasing all these cysteine thiol bridges.
And the links in the chains fall apart a little bit?
Yeah, the links in the chains fall apart. Then you curl your hair, leave it in curlers, and rinse the beta-mercaptoethanol out. And the sulfhydryl bridges reform, but they're at a different place in the protein. And you'll find sulfhydryls in tau, beta-amyloid, and alpha-synuclein. And Dr. Veach did a study where he treated animals that were models of Alzheimer's and found that you didn't get the tau or the alpha-synuclein or the beta-amyloid deposits. And he also treated nerve cells with beta-hydroxybutyrate and found that they weren't killed by the paraquats and the MPP+.
Wow.
So it's
so everything's kind of circling back or pointing to this voltage, the battery, the NADPH that we've been talking about.
Now there's certainly a number of other mechanisms of aging that we think could be related to ketone bodies, and we reviewed a lot of those. One we didn't review was autophagy, because the paper would have been too long, but that's a very neat thing too.
Absolutely. Yeah, and I would love to kind of transition a little bit to the other paper with mild-cognitive impairment and TBI. I think you talked about it gets a little complex with the mitochondrial transition pore and all that sort of stuff, but I think it kind of, again, goes back to this mitochondria that we've been talking about, and kind of a key way through which intermittent fasting and ketosis and all that affects our body is through mitochondrial health.
Sure. Well, I had a pastor. I guess I've had a lot of pastors. This guy, he got hit in the head by his wife with a pie plate. Now, it wasn't malicious or anything, but he got a concussion. He was going to graduate school and he couldn't concentrate and he had fatigue. And he was standing in the church and he says, "Welcome to," and he named some church that wasn't our church. And I was like, that is really odd.
Yeah.
You know, what's going on in his brain? And I'd had another friend who had a concussion and it really affected his life so that he tried to commit suicide, and it took him a long time to recover from that. And I think you see a high incidence of suicide in concussions, and you know, in the NFL you see it. And the way that the radiation responded to the beta-hydroxybutyrate is, I think, the way that concussions will respond, because I told my pastor about this coffee. He got on the regimen and he says to me, "This is amazing. I'm telling everyone that I talked to," because he had energy and he could concentrate. That was a concussion. And nobody's tested this in concussion. We wanted to test it in the military. They never saw fit to pony up. It takes a lot of money. And also, I used to work in toxicology at the University of Maryland, and the University of Maryland is spending a lot of money from Under Armour to build not just a practice stadium, but to also build this science project that will address traumatic brain injury. So I contacted them and said, "Hey, you know, why don't you do this?" And they gave me the name of a leading specialist who had written a paper, and his paper was, "We've had 30 different clinical trials in traumatic brain injury and they all failed." I'm thinking, I know one. You know, it's like, but he said that we can't deal with the nitric oxide, the NOx, it's NADPH oxidase, that is downstream from the initial trauma. So it's not the initial trauma, it's the things that follow on. It's a cascade that leads to more inflammation, and the other inflammation is actually what's more damaging.
So it's like a vicious cycle in a sense. It causes more damage. Are those like repair enzymes that are initially protective at first and then they spiral out of control?
Well, inflammation is designed to actually kill cells that are having problems. You have to get rid of cells that are, if the battery's dead, you got to dump them. And you don't want to let them lyse. And you have to gently wrap them up, bury them. And the same thing with mitochondria. So with regard to traumatic brain injury, I think that it will work. This gentleman who wrote the paper saying we're 0 for 30 also told me that he has no time for anything because the drug companies are really pushing this, and every available minute that any specialist in this field has is going to be taken up by one of the companies that has money. But you know, if someone from the NFL wanted to test this, they've got a lot of people, just give them a dose 24 hours after the exposure, just like we do in the radiation, and see what happens.
To help prevent some of that downstream inflammation. And can that kind of self-resolve with the right nutritional tools and therapy?
I don't know.
Okay, it's still being investigated.
My experience with the people who I know who've had serious problems with concussions, they do eventually recover to a large extent, but I don't know how.
Well, Bill, really appreciate you coming on the show and sharing your wisdom and knowledge. I know you have an online support group for folks with Parkinson's, and people may want to reach out to you. How can they do that?
Well, I've been supporting people by email, and that's something that I really enjoy doing, but there are 500,000 Parkinson's patients, and I've never really put this out there to the world, and I would get swamped with emails. So I made an online course where I think that people can come together and help each other. You know, I mentioned that other people don't drink the coffee with the butter and the cream. They came up with their own recipes. And if you have a community that can talk and share experiences and troubleshoot and still be somewhat controlled, I think there's 4 roles. You need a cook, because nobody sells food that's good. You need a coach who can tell you the difference between a protein and a carbohydrate. You need a nutritionist, someone like yourself, and should be ideally someone who's certified and knows ketogenic. And there are a lot of them because of the Charlie Foundation and the epilepsy work. And then the last thing you need is your doctor. Don't do this without your doctor. And when you talk to your doctor, say, will this hurt me? You know, and they won't know what it is. No Parkinson's doctor knows about this that I know of. But there should be resources that the doctors can find on this website. It's called the 4th Food Group, and it's a class, and it's a learning community, and it's very primitive now, but I hope that as people start to log on and hear about it, it's all automated. I don't have to,
Sure.
you know, they get an email back and sign on.
And what's the website for that?
4th Food Group.
4thfoodgroup.com. Okay.
And it's spelled out. It's
Yeah.
not, it's FOUR.
TH.
Yeah.
Gotcha. Yeah.
There is one other aspect of this treatment. It's not, I can't call it a treatment for a medical problem. And I do want people to go to see their doctors. And also, you have to realize that I can't skip medication. Just because it adds all these things to the existing medication. If I go without medication, I'm a basket case.
Right. Yeah. Important to follow the protocol per your doctor, but add this as a way to help with symptoms.
And especially if you're going to a full-blown ketogenic diet, you want to check a few things with your doctor before you get into that. And your nutritionist, if you hire one, will be able to tell you what those things are.
Great. Bill, really appreciate you coming on the show.
Okay.
Thanks so much.